Hi everybody, this is Manny with Classic Auto Repair. Today we're looking at the completion of a air conditioning upgrade project on this 1967 GTO. We also did some upgrades on the cooling system as well on this car. Just kind of give you a look around on the vehicle. It had air conditioning originally factory, but the system was very, very bad. It had a lot of broken parts, a lot of things that were not correct or original. So it was a better solution here to install the aftermarket air conditioning systems and heat control, climate control kits that are out there. This one mounts right underneath the dash. Once you take out all of the heater ducts, AC ducts, the evaporator case, heater core. Once all that's removed, there's plenty of space on these 67s to get the aftermarket evaporator cases in the car. The control head is mounted right under the steering column. You can see it right there. I just lit it up. And it controls your fan speed, the computer-controlled electric motors that drive the flapper doors control the direction of the airflow. So you can have it go up as a defrost setting through your vents and heat down at the floor. And then this one right here controls whether you want cold air or hot air coming out of the vents. And then finally, this engages the compressor under the hood to start the air conditioning system. So it's usually just a flip of the fan switch, like a new car, to get the AC system up and running. The nice thing about these kits is it's all brand new, it's computer controlled, very efficient and reliable. That's the problem with working on old OEM original air conditioning kits, is they don't tend to work for very long if you do get them up and running. This one does allow us to keep the original glove box. It was set back far enough so we could maintain that. A lot of the kits will come with a smaller glove box, and that's about the only sacrifice you have on the interior of the vehicle. It's a real nice 67, pretty white interior. Take you around to the back side. Then back over here to turn off the lights. Let's take a look under the hood. Show you what we have there. So here's everything that we did on the car. First of all, we swapped out the old original radiator for a high efficiency aluminum 4-row. This is going to maximize cooling on the vehicle, which you're going to definitely want in the Texas summers. Running the air conditioning, you need very good cooling on these engines. And that's one of the biggest upgrades you can make, is getting a high efficiency radiator. Then we also installed, you can kind of hardly see it there, but up underneath the, behind the bumper, in front of the air conditioning condenser, which is new, we also installed an electric fan. And this fan helps push air when you're not moving in the vehicle, when it's set at a stoplight, stopped at a drive-through or something where you're cruising, maybe in a parade where you're not developing a lot of RPMs. When you're not turning the engine fast, then this fan blade from the motor is turning very slow, about 800 to 900 RPMs instead of the 2,000 to 3,000 that it's turning when you're cruising down the road on the highway. You're also, when you're driving fast, 30, 40 miles per hour, you're getting a lot of airflow through the front of the grill, and that's helping cool the engine as well. But when you're sitting at a standstill, the fan's turning slow. This electric fan up here in the front is going to be turning at its max speed all the time whenever the compressor is engaged. It has a sensor here that when the compressor is engaged, it knows air conditioning is on, so it needs to cool the condenser, which makes the air conditioning work better and colder. So this system has been designed, and it's a little computer controller head right here. Has its own built-in relay, a couple of fuses, and it has a setting here that when this computer probe thing here senses the clutch is engaged on the air conditioning, then it's going to go ahead and turn on that electric fan. It also has a probe wire, and the probe wire goes right here and into the radiator. You can kind of see it poking through down there. What that does is it measures the constant temperature of the engine and the cooling system. And based on a temperature setting, usually about 160, 165, it will engage the electric fan because it's hit that threshold for temperature setting. So this also, again, helps even with the air conditioning turned off. If you're sitting in a high heat condition, for example, at a railroad stop, you're waiting 5 minutes for the train to pass, this system will detect, based on this probe right here, it will detect that the temperature is rising on the engine because it's not moving, and it'll go ahead and kick on that electric fan for you. Now, usually we go with a sand-in compressor on these, but in this case, because it had factory air, it had this very rare and very complicated aluminum bracket here for the original A6 compressor. So what we did was we bought a new compressor because the old one was just, the clutch was bad, the compressor was leaking. Went ahead and put a new compressor on it with a new clutch. And this allows us to have a brand new compressor sitting on the original design. So in this particular case for the installation, we were able to do it with the original style compressor instead of going with the upgraded smaller sand-in compressor. The other thing that we did was we adapted the manifold on the back to the new fitting styles, which is what these are right here. It has your ports for the air conditioning to charge the Freon here and to evacuate the system. All of these hoses are custom made. They're professionally crimped so that it holds that pressure and doesn't blow when the temperatures go up and you get up in the 300 to 400 pound high pressure side. Over here on the high pressure side, you're not going to blow that hose. Here is the one of the controllers that controls the heater control valve. This goes back to the control head under the dash, and when you turn the dial to hot, this motor energizes and it opens the valve here, and this allows the engine coolant to enter the cabin, go through the tubes, go through the heater core, blow through the fan, creates that heat inside of the cabin on those cold winter days, and then it comes back so that it can go back into the cooling system and run through the radiator and the engine to keep it cool as well. And the other nice thing is how clean the installations are, because you're only having four tubes going through the firewall. In the old OEM systems, you have these huge cases that go here, fills up this half of this firewall with a lot of the old style air conditioning components. All of that is removed. We build some plates and fill the holes with silicone and then seal them up with these plates, put the screws in, paint it black. It looks factory. It's a much cleaner installation. There's less things here to get in the way, especially when you're changing spark plugs or you're doing any kind of work on the car. This opens up a lot of the area of it. Then these lines run over here. They're all clamped down so that they don't get in the way of other moving parts. And then right here is your accumulator, or what they call a dryer. This is basically the filtration system for your air conditioning. And it has a fine filter in there that cleans. You definitely want to put one of these canisters on anytime that you're changing a compressor or any major part on the air conditioning system. The condenser is sitting, as I showed you in the other picture of the fan, it sits right here in front of the radiator. It's kind of hard to see on this car, but there it is up underneath there. You can see that there's a smaller radiator, and that one is for your Freon system. It helps cool the temperatures on the Freon so that it works better and more efficiently. So you want to make sure that you put a new one of these on anytime you're upgrading your system, because they tend to have a bunch of rock chips and bugs, and they get a lot of the road debris is what damages these and puts holes in them, and then you get leaks on those condensers, which makes your Freon escape from the system, and then you lose your cooling. Other than that, this is a pretty original car as far as what's been modified on it. A little bit of engine work there. You can see it's got an updated carburetor intake. Alternator looks a little pretty fresh, which you definitely want to make sure these things are charging well, because you're adding the electric fans. You're adding the fans and all the computer control equipment that goes under the dash. Normally it's a pretty easy swap out for the items you already are running, like the old blower heater motor, which draws more amps, requires even more on the system as far as the load that it puts on it. Everything that we put in is high efficiency. They're brand new, so a lot of it has been designed to not put too much pressure on the electrical system when they're in full operation mode. While we put all the new hoses on here for the AC system, we're also dealing with the heating system, because it is also part of this climate control kit. As I had mentioned about the heater control valve here, it also has all brand new heater hoses going to a brand new heater core that's part of the evaporator kit. And then these hoses run right to the engine, to the intake, and then to the water pump down here below. You can kind of see it connecting right there. So again, this is a good example of a client that was wanting some cold air conditioning, some good heating in the wintertime. And these new upgrades that we install here allow us to get that, to reach those client requests, which is to make sure that the system is always reliable and it doesn't cause another condition like an overheat condition in the vehicle. So again, hope you enjoyed watching this 1967 Pontiac GTO receiving a air conditioning upgrade from Classic Auto Repair. If you have any needs, please give us a call or check us out on the website, www.texasrepairshop.com.